Hey students, how you doing? Good to have you back. I'm going to teach you another short lesson on average velocity. This will be section 2.2 of your physics notebook lab book that you have there. All right, so we're going to talk about average velocity. I want you to think about the average velocity. Imagine you're driving down a road, you're in a car and you're going somewhere and you leave your house. You may stop at a stop sign, so your velocity goes down to zero. And then you travel a little bit farther and you have to slow down to make a left-hand turn. So you slow down and then you speed up after you've to reach the speed limit to that turn, and then you slow down a little bit more to get onto the highway. Then you're on, let's say, an interstate highway, and then you're going a good 70, 80 miles per hour. Then you're going a velocity. Then you get off that highway. You slow down to merge onto the state road. You travel for a little while, stop at a traffic circle, say on your way to school, and then you turn into your school and you stop. So over the course of the entire trip, you have gone faster and you've gone slower. You've gone faster for a longer period of time when you're on, say, the interstate, and then you kind of did some stop and go traffic based on the lights and the different times you had to wait to turn. Okay, so what you would do, you would get the average velocity over that time. So what we're going to learn the concept today is taking the average of your velocity over that whole trip. Now, there is a difference between velocity and speed that we may have to think about. Speed is not a vector. Speed is just the magnitude of an object's motion. Okay, it doesn't think about or regard direction. So going 70 miles per hour on the highway is just that. It's the speed. That's why it's called a speedometer in a car. Okay, because it's measuring your speed, not your direction. Okay, velocity is speed, but it includes direction. So it's a separate terminology, separate word. Velocity means it's you're going 60 or 70 miles an hour southeast on the highway. So that's a vector. So you must have so if you're reporting a velocity, it's going to have a magnitude, a number, a unit, usually meters per second, and a direction. Okay, so let's talk about average velocity here. So here's what you understand. Velocity is the amount of distance in kilometers or meters over time, which is usually reported in seconds. So you can think of velocity as meters per second or kilometers per second. Okay, so let's talk about what average velocity is. Okay, average velocity, here's an example problem. A runner um, the runner, as a function of time, is plotted moving along the x-axis coordinate system. So imagine a runner is running along a flat surface, and we'll call that our x-axis. If we're running along a road or a sidewalk or a nice field, okay, and then that runner's distance is measured. It started from 50 meter. So let's say it started on the 50-meter yard line of a football field, and it moved, that runner, she moved to the 30.5-meter yard line, okay? And it took her 3 seconds to run from the 50 to the 30.5, okay? So we want to know the runner's average pace. So what we have to do is we have to take the final, where she ended up, and subtract where she started from. So her total distance will be from 30 minus 50. Okay, and that's going to be her change in distance. Okay, so I'll talk about this little triangle in a minute. And then we have to divide that by the time that it took, and that would be the change in time. So here's another look at that. So her displacement, the runner's displacement she started at the 30.5-meter yard line. I keep saying yard line. She started at the 30.5-meter line, and she ran to the 50-meter line. Okay, so where she started from, where she ended up, this is where she started from. So that is going to be to subtract those two. You add those two up, it's going to be negative 19.5 meters. So that is her change in her x direction. So anytime you see a triangle in physics class and chemistry class, if you've taken chemistry or will take chemistry one day, that always means change in it. It's also called, it's the Greek letter D for delta. So delta means change in. Okay, so this is the change in the x distance. So she moved 19 meters, and we're going to say she moved in a negative direction because her final distance was at the 30.5 meter line, and her final was at the 50. So she changed a negative. So 30.5 minus 50 is negative 19.5. And her overall time, she started at time 0 when the clock was started, and she ended at exactly 3.00 seconds. So her change in distance over the change in time, it means that her velocity is negative 6.5 meters per second. Okay, so what I want you to get familiar with is maybe how to read initial and final displacement or x position, and then the beginning and end time. So that is kind of what we're understanding in average velocity. There are a few practice problems I assigned you. I'd like for you to try a few of these. Read over this section 2.2. Read it thoroughly. Look at some of the example problems that are done. One of them is right here. And then do that practice, and we'll cover that together again in class. I'll talk to you soon. Bye-bye.